Physicists say that the universe had its origin in an event known as the Big Bang approximately 13.7 billion years ago. However, the question that arises is, what caused that explosion and why did it occur? Over time, we have been researching and studying the science and the beginning of the universe, and its history has been the predominant explanation for everything we have observed. There have now been countless studies, and thousands of scientists have worked on the research, and the data collected has always backed the theory of the Big Bang as the main explanation for how the universe was created. According to this theory, dark energy is a form of energy even more abundant than galactic energy and is thought to be an anti-gravitational force accountable for the ongoing expansion of the universe since the Big Bang. Science today is very different from what it was in the past, and using technological advances, new theories emerge. Many times we discover that things we thought to be absolutely true are far from being so. Michio has raised the Big Bang's official debunking. This is because the James Webb Telescope has detected 750 new galaxies that look nothing like what was expected. This provides a fresh point of view and leads us to delve deeper into how the James Webb Telescope is changing our understanding of the universe as a whole. Join us on this amazing journey beyond the far reaches of the observable universe to discover more details about the immense number of new galaxies that have been discovered. If you are interested in keeping up to date with news from the universe, surround yourself with our channel and subscribe. Be sure to like this video, share it to reach a larger audience, and activate the notification bell. The images of new galaxies captured by the James Webb Telescope are absolutely stunning. In a single image, we can see hundreds of galaxies as a whole, and the beauty and power of these photos are stunning, something that cannot be overlooked. However, what seems to amaze the average person is precisely the opposite for researchers. These images are amazing to them, but they do not match what the scientists expected to see based on their theories. In fact, many more galaxies are being seen than expected, and these galaxies are different from the rest. They are smaller than imagined and have a truly remarkable age. These surprises are generating some panic among scientists. There is even an article that begins with the word panic in its title, which shows the seriousness of the situation. These galaxies have completely changed what was supposed to be. According to established theories, which have been around for a long time, the Big Bang theory has been proposed as the main explanation for the origins of our vast universe. Based on this theory, approximately 13.7 billion years ago, the universe began its existence through some kind of mysterious cosmic event. However, these new images challenge the definitive account of the creation of the cosmos. As previously understood, these striking images captured by the James Webb Telescope have put our comprehension of the source of the universe in question. Specifically, these images directly contradict the Big Bang hypothesis, which has long been considered an unquestioned truth by most theorists of cosmology. The galaxies depicted in these photographs appear to be too small, smooth, old, and numerous compared to the predictions of the Big Bang hypothesis. The fact that the observed galaxies are 2 to 3 times smaller than similar galaxies imaged by the Hubble Space Telescope completely defies the expected behavior in an expanding universe. According to the hypothesis, as space and time expand, objects should appear larger as distance increases. However, these James Webb observations show galaxies that defy that anticipation. Moreover, the smoothness of these galaxies is totally unexpected. According to the Big Bang theory, galaxies should show variations and irregularities in their structures because of their dynamic creation and development. However, the images reveal unusually smooth galaxies without the degree of difficulty and roughness that one would normally expect to observe in older galaxies. This defies the expected time sequence for the development of galaxies over time in the context of the Big Bang theory. At the beginning of the universe, all matter, energy, and building blocks of the cosmos were compressed into an extreme singularity, a concentrated point. At this point, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of singularity is based on our current understanding of the laws of physics, especially the equations of Albert Einstein's general relativity. All matter and energy in the universe existed in an extraordinarily compressed form within the singularity. This extreme density implies that an enormous amount of mass and energy was concentrated in an infinitesimally small space. Under extreme pressure and conditions of density like those present in the singularity, heat is unimaginable. The internal temperature of a singularity would be too high for any observable or reproducible temperature in our current comprehension of the cosmos. The energy stored in this hot, dense point was the seed from which the entire universe, as we know it today, began. The singularity signaled the beginning of our cosmos, the place where everything began. After the initial singularity, the universe began its journey of expansion and inflation. This process occurred over approximately 13.7 billion years, giving rise to the universe as it currently exists. The beginning of the universe's expansion was an extraordinary and rapid burst known as cosmic inflation. During this phase, the universe expanded at an unimaginable speed, far exceeding the speed of light. It is as if the very fabric of space stretched, pulling everything within it along with it. Cosmic inflation played a massive role in the creation of the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and paved the way for the subsequent creation of stars, galaxies, and other cosmic structures. As the whole universe continued to expand, the rate of expansion gradually slowed. It is important to note that, although there was rapid cosmic inflation in the initial period, the universe continued to expand at a measurable rate. This cosmic expansion refers to the continuous expansion of the universe. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies. Redshift shows that, as the universe grows, light waves are stretched and shifted to longer wavelengths, moving them toward the red end of the spectrum. While the universe expanded, all the matter that makes up our universe was compressed into an incredibly small volume. It was evident that matter cannot survive in such a compact space. Therefore, alterations occurred as the universe expanded and cooled. Protons, electrons, and neutrons, for example, started to interact with the energy and light surrounding them. These interactions played a key role in the formation of matter in the universe during the first few minutes following the Big Bang. This process is regarded as nucleosynthesis. Chaotic and disrupted galaxies due to multiple collisions were expected to be observed, but the pictures captured by JWST tell a different story. Instead of chaotic galaxies, the images reveal well-organized disks and spiral structures similar to the galaxies we see in today's universe. This unexpected observation challenges the idea that mergers are a common process in galaxy evolution. If these new galaxies have not experienced many or any mergers, it becomes unlikely that small galaxies will grow and become hundreds of times larger as expected. This implies that these galaxies never shrank in size originally. Furthermore, the optical illusion predicted by the expanding universe hypothesis, where objects appear smaller due to expansion, does not hold in this instance. Therefore, what we have believed so far turns out to be a falsehood. In addition, the age and abundance of galaxies revealed by the James Webb Space Telescope also pose a problem for the validity of the Big Bang theory. The JWST is equipped with filters that allow imaging in the infrared part of the spectrum, which facilitates the study of the colors of distant galaxies. By analyzing these colors, astronomers can estimate the age of stars and galaxies. I hope you like this video. If so, don't forget to hit the like button, share this video to reach more people, and make sure you subscribe to the channel to avoid missing our next video.